Alright, good afternoon everyone. Welcome to today's Sec 2 E-Math lesson with me, Teacher Jason over here. I hope you are doing good, doing well with more revision to come. Alright, so do not worry, do not get daunted. We are going to get to the lesson straight ahead right now. Alright, let's go in about 5 seconds, or we can actually start right now. Alright, so general rules: just be patient and understanding, observe gracious and respectful behavior even in digital space. So as you're writing down, just take note. And lastly, if you require any if you have any questions, please ask the relevant ones and as well as the good ones if possible. And in fact, any question is a good question as long as it is in context for today's lesson. Alright, so what are we going through today? We are actually going to a few parts. Firstly, our Pythagoras theorem, trigonometry and further trigonometry, and lastly, applications of it. So a lot of recap over here needed first before we go on to questions that combines everything over here. So let's get to the revision, which is more of the absorbing part. Alright, so I hope you guys know all the concepts already. Anything not clear, just sound off along the way. Okay, just write it out. Now, first up, when we go on to our geometry, first things first, you always have a look at our Pythagoras theorem. In fact, two ways to write it. Yes, I've started recording, alright. I've started it in the OBS settings, so you're not able to see. Don't worry, moderator. So what happens is over here, first up, Pythagoras theorem. Okay, just remember your two sides that form the right angle, and then you square the sum of them. So in this case, BC square plus AC square is equals to, in this case, AB square. Or in fact, your very famous A square plus B square plus C square. Where we take note over here, C is the hypotenuse that we are forming. So C is my hypotenuse, AB over here, AC is the side, so I have AC as my side over here. And lastly, BC is one of the other side. So this is my Pythagoras theorem. Alright, this should be familiar to everyone here as such. So then again, these are the sides that I have. Okay, now moving on from Pythagoras theorem, as we delve deeper down into trigonometry with a right angle triangle, we bring down to our trig ratios, and that is where we have it, our tuakaso. So let me just give a test to everyone. In this case, okay, I believe we all know this is the hypotenuse. This should be clear. Okay, but in this case, based on this angle over here, can anyone tell me which side will be my opposite? Okay, you have two choices, A, B or B, C. Which side will be my opposite? Okay, based on the angle over here. Because we call trig ratios, it is based on the angle. Which side will be my opposite over here? You have either A, B or B, C. Alright, I'll give you a few seconds to write your response so that I can keep track. Alright, okay, let's give it a while. A, B or B, C. Alright, Nguyen over here has an answer. Alright, that's correct. Anybody else wants to try? Which one is my opposite? Alright, since I've got my answer, very good over here. So AB, you realize it's going to be my very good, Lamin. Perfect over here. So realize over here, AB is my opposite, and henceforth, because it's opposite my angle. And lastly, over here, BC is what we call my adjacent, ADJ. Alright, adjacent over here. So therefore, tuakaso, following the alphabets over here, O, following the alphabets over here, O, A, and H. T, each of the first alphabet over here, let's recap, represents your tangent, cosine, and sine. So whenever we write trigo ratios, we always write with reference to an angle. So in this case, tuakaso, tua in this case, tangent of the angle, it's going to be opposite over adjacent. Okay, just a recap for everyone. Cosine is going to be cosine of the angle is going to be adjacent over hypotenuse. And lastly, for sine theta, okay, it's going to be opposite over hypotenuse. So tuakaso in another dialect, in Hokkien, if I recall, it's known as big leg auntie. Okay, I'm not discriminating any aunties or anything, but if tuakaso is hard to remember, in another dialect, it's called big leg auntie. So I hope this is an interesting fact for those who wants to remember. And otherwise, if this is too much, tuakaso will do good as well. Okay, following up next. Now, in terms of trigo ratios, what happens is we may not always have acute angles. We can have obtuse angles, and usually we focus on these two, sine theta and cosine theta. So can anyone try to let me know sine theta in terms of my obtuse angle, what is it equals to? Okay, let's give it a shot. So we call my obtuse angle is 180 minus theta, where in this case my theta has to be acute. Okay, so let's give it a shot. Sine 180 minus theta. Okay, in this case, is it minus sine 180 minus theta or positive? Give it a try. Is it negative or positive? Because when we talk about acute, it's going to be this one. Okay, so if I reference in this case 180 degrees minus theta, is it just sine 180 minus theta or is it negative? So do I include a negative or not? Alright, very good, Denise. That's good. That's correct, actually. Okay, anybody else wants to try? Is it positive sign or negative sign? Very good, Denise. That's good to hear. That's good. That's good. Okay, that's good for the second one. So I guess most of you all got it. Positive for sine, but for cosine, it's going to be negative. Alright, so just take note over here. Okay, if you do want to know why is it like this, okay, you can view the previous Genie class recordings to understand them. Alright, but otherwise, let's move on. A lot of revisions to go over here. Now, from here, we can summarize as such, based on what we know. If you look at sine theta, if it's acute, it's going to be positive for both, as you can see from what we have. Theta is acute, sine theta, cosine theta, it's going to be positive for both. But if it's obtuse, it's only going to be positive for sine, but negative for cosine. Alright, so just take note from there, positive for sine, negative for cosine. Alright, so just take note from there. Okay, moving on, further more revisions to go. Now with regards to your sine, cosine, you realize all these particular angles only work if they are right angles. But what happens if you do not have a right angle triangle? So that's where we have our sine rule over here. So there are two ways to do it. Finding length, what happens is when we want to find something, that particular item will be at the numerator. So what do I mean? So let's say I want to find this particular length over here. Let's say I want to find BC. So let's recap. It's going to be a fraction over here. Okay, it's going to be a fraction over here. Can anybody tell me what should I fill in at the top if I'm looking at this side? What is the alphabet that I should put in here at the top if I'm looking at this side? What is the alphabet? There are only three alphabets, A, B, or C. Very good, Denise. Anybody else wants to try? What is the alphabet I should put? A, B, or C? Very good, No and Dang. Perfect over there. Anybody else still wants to try? Alright, perfect. So you realize over here, finding length, I have A at the top. And then what happens at the bottom? It's the sine of the angle. Why is it so? Sine rule, as the name mentioned. Okay, sine rule. So A over here with reference to this angle over here. So that's why it's my sine rule. Alright, so A over sine A. And you actually repeat them for the other alphabets as well. So A over sine A, B over sine B, and C over sine C. So that's how we find the length. Now if we want to find an angle, okay, actually the formula is the same because we're just flipping the fraction around. But why is finding angles written in this particular manner? Again, if we want to find something, it is usually better to actually put it at the numerator. Alright, so in this case, let's say I want to find the angle A. The angle A will be at the numerator. I mean the length in this case. If I want to find the length A, the A will be at the numerator. If I want to find the angle, my angle will be at the numerator. Both of them are the same way, but in this case, it is easier to locate it in that manner. Alright, okay, so now, moving on. Cosine rule. Okay, so moving on to my cosine rule. Sorry, my transition a bit lagging over here. Cosine rule. Now, in this case, let's take a look. Finding length. Suppose, let's say, if I were to talk about cosine rule. Again, let's take reference to my vertex A over here and my side A over here. So finding length, length has to be the subject. It's easier to do it that way. So in this case, let's say A squared. Okay, now this one you realize it's very similar to my Pythagoras theorem. Okay, I have B squared plus C squared, but there is something else I need to add at the end. Can anybody tell me what is this particular expression I need to add at the end? This is like my Pythagoras theorem plus a little add-on. Does anybody want to finish this for me? A squared equals to B squared plus C squared. What else do I need to add at the end over here? Anybody else wants to give it a very good shot over here? Okay, let me give a hint. There's a negative sign that's involved. Minus. Okay, what else do I need? Okay, I'm seeing good response over here. That's good. Seeing a 2. Okay, it's not AB. Take note, it's not AB. Remember. Okay, my angle, my side I want to find, B squared plus C squared minus. Alright, see some responses. Very good. 2BC cosine A. Alright, so it's with reference to my sides. And we call for cosine rule when we solve it with the included angle. Okay, what do I mean by the included angle? Okay, because that means when I label the sides over here, my angle is included in the middle. That's the notion of what it means to be included over here. Okay, therefore, again, when we want to find the angle, let's recap what I said. Cosine of the angle, the subject will be at the left-hand side. So all you realize finding angle is just manipulating this. And I hope you all realize that in this case, it's going to be just B squared plus C squared minus A squared. And I divide it with 2BC. So that's the notion, and I hope you all got it down. Alright? Okay, lastly, last recap. Finally, before we move on to our first bubble question, area of a triangle. Alright, suppose, let's say we are focusing on these two sides and this vertex over here, these are given. Does anybody want to share what is the area of a triangle given this side? Take note, there's no right angles over here. Do not force a right angle. What happens if A and B are given and I have my angle C? What is the formula? Okay, I'll give you a few seconds to type it out because I understand this is a little bit of a hassle. Alright, very good, Denise. Anybody else wants to give it a shot? What is the formula? Okay, let me give a hint. Okay, Wheel of Fortune, math addition. Okay, I have a half. Okay, very good. Okay, AB sine C. Alright, so take note what is all these things over here. My sides that are forming over here, sorry, I should not do this. My sides that are forming over here, suppose I have my fingers as the sides of the triangle. Okay, the angle is the one that is included over here, which means included with the sides. Okay, so always remember my C over here is the included angle. Similar to the cosine rule, take note, it has to be the included angle. Did I emphasize this? Okay, my cosine, in this case cosine A, yes, I emphasized this, but let me just write it out. It has to be the included angle for the A over here and for my C over here as well. Alright, with all these concepts, let's see how the bubble questions will come back. Okay, first one, bubble question 1. Alright, so read the question carefully. I want the cosine of PQR. Alright, take note, when I want to find cosine of PQR, what am I trying to find out? Okay, what is cosine PQR? Alright, launching my bubble launcher in 3, 2, 1, let's go. Okay, take note, I want cosine of PQR. Okay, so some of y'all have fallen into the trap. Take note, PQR, I'm finding PQR over here. Okay, cosine of PQR, what does it mean? Take note, I want cosine. Okay, some of y'all went to straight away find another ratio, so take note. Okay, you have about 1 minute left. Okay, my responses are going good. That's good to see. Take note, where is my angle PQR? Okay, always try to work backwards with your answer in mind. Where is my angle PQR? And with this angle PQR, how do I locate the cosine of a angle? In this case, how is this angle working about? Okay, you have about 30 seconds. Okay, it's all going good. You have about 30 seconds. Alright, seems like all the responses are going a little bit even over here. Alright, you have about a few more seconds to go. Alright, last 5 seconds. Last 3. Alright, my responses are a bit mixed, but let's see what we have. Okay, so take note, I want to find the cosine of an angle. This is an acute angle. This is an obtuse angle. So let's backtrack a bit. Obtuse angle, there is a particular formula that I need to know. Okay, this one you recall is 180 degrees minus theta, where I reference to this angle such that it is acute. So now we actually have to find what is cosine of theta in this case. But we call cosine is what? Adjacent over hypotenuse. Have I got my hypotenuse yet? It's not yet found. So what can I do to find my hypotenuse over here? Again, everyone tell me the famous mathematician that you always follow with a right angle triangle. What is that theorem we always use? Give you a few seconds and you always write this sentence by starting with very good Pranav, very good Ian, perfect over there. Anybody else wants to give it a try before I write it out? Give me a moment. Yep, anybody else wants to give it a try before I write it out? Okay, so I see the very nice names over here using Pythagoras. Yes, so you always see Pythagoras theorem over here. Mr. Pythagoras always links to right angle triangles. So you see right angle triangles, try to see whether you can use your trigo ratios or Pythagoras theorem. In this case, I will just quickly write the working out. In this case, it's going to be QR is equals to square root. Take note, it's the square root because it's not QR square, but QR is equals to the square root of QS plus RS square. Okay, that's where just manipulate with a working square root of 12.6 square plus 9.8 square. That's gonna be square root of 254.8. And again, because this is a recurring number, we write to our as much significance figures or decimal places as possible, preferably 5SF or 5 decimal places. Sorry for that. Now let's take a look. Now cosine of PQR. What is it? Okay, let me continue my working over here. Now cosine of PQR. Let's recap. Cosine of PQR. Okay. If you were to recall, cosine of PQR is my 180 minus theta. What is this equals to? Remember, it's going to be very nice sine acute. Okay, what do you mean by that, Pranav? Okay, it's going to be, there's a negative sign that's involved over here. It's going to be negative of cosine theta. What is my theta? SQR. Yeah, but I think I get what you roughly mean, Pranav. Just be careful with your wordings over there, yeah? Okay, SQR over here. SQR. This is my SQR. What's theta? That is where, since we know this is going to be 15.96245, linking back to your cosine again. What is it? Adjacent over hypotenuse. Okay, I roughly get what you mean, but just take note, the signs have to be equal. Over there, I cannot have cosine equals to sine, sine equals to cosine. I think that one refers to 90 degrees, but I don't think you need to go through it for this question. Okay, so 12.6 is my adjacent over 15.96249. Alright, give it up. Okay, you don't have to do the inverse because it's just evaluating the cosine of it, 0.7. Take note, it's going to be 8955. Round off to 3SF. 935, sorry for that. It's going to be 935. Round off to 3SF, that's where I have negative 0.89. Alright, so just be assure and be very careful where is your obtuse angle and how we solve them. Okay, but otherwise, not too bad of an attempt over here. I hope you guys understood my explanation for this. Alright, so let me just give a shout out. Click 1 if you fully understand, 2 if it's half, 3 if you totally do not know. Alright, feedback will be totally appreciated over here. Alright, thank you, Pranav. Alright, I'm glad you did understand. For the rest, 1 if you fully understand, 2 if it's half, 3 if you totally do not understand. Okay, so I have responses from that. Okay, that's good to hear. Okay, that's good. Okay, for those I understand, because this is actually more of a set 3 concept. So for those who did 2, I saw your sites, you're more or less set 2. So don't worry about it, alright? Okay, as we proceed on, you will understand how this works out. Okay, because this is a bit of a second layer. Okay, now let's move on over here to bubble question 2. Alright, so bubble question 2 in this case, and bubble questions, I would say the next 3 bubble questions are linked. So 2, 3, 4 are actually linked to each other. Okay, so given 2 triangles, I want to find the length of QS. Now, how do I do so? Okay, sorry, is that the first one? Yes, how do I find the length of QS? Given an angle, given a side, now how would I do it? Okay, launching my bubble launcher. Give me a moment. Wait a minute. Okay, launching the bubble. That's correct. Yeah, that's right. What am I doing? Okay, I want to find the length of QS. Sorry, I was a bit dazing off just now. Launching the bubble launcher in 3, 2, 1. Let's go. All right, be very, very clear on what is the triangle we need to use over here. All right, so for those who are Sec 2, this concept may not be clear, so don't worry about it. Okay, it's actually my cosine rule. Okay, so you might be a bit lost, but don't worry about it. Okay, again, this will be gone through in your Sec 3 content. Okay, but seeing the responses is all good. All right. Okay, so over here, I need. Okay, always ask yourself. I need to find QS. Okay, so what is it? Okay, some of you are actually using another attempt, but take note over here. They only tell you 2 triangles. Okay, so yes, I see a mixture of 2 attempts. So take note over here. I have 4 more seconds. Okay, so you realize what happens is this. Now, this question is a bit gray because they only tell you 2 triangles. Some of you, okay, there's a mixture between 2 responses, 2 and 3, which I understand why. Because some of you actually might have used cosine rule. Sine rule. If you work out with sine rule and you take 180 minus 129, you realize this can be correct, but take note. Did they mention that RQP is a straight line? Or in anywhere in the question? So therefore, don't trust the diagram, always trust the description. If they never say it's a straight line, please don't assume it's a straight line. In this case, since we cannot assume this is a straight line, the only way is to work out this triangle first, which is in this case, your cosine rule. Because I have the side that I want to find, remember? So using cosine rule, okay, I have QS square again equals to the 2 sides and my included angle. So my 2 sides and my included angle. Okay, so just work it out. I have 7 square. That is right, Pranav. That's good to hear. And yes, once bitten, twice shy. But do not worry about it. That's where we all learn together. Let's have a positive mindset over here while I fill in the working. So 2, 7 cosine. Okay, please don't do this in your workings. Okay, the cosine 79 is supposed to be here. Unfortunately, my handwriting is a little bit too big. My apologies. I'll just carry on with my working as well. 8090633. After that, what happens? I want to find QS. So that's where I take the square root. Yes, square root over here. 80.90633. Taking the square root again, just doing this 899,479. Rounding up to 3SF, that's where I have 8.99 cm. Alright, so remember guys, moral of the story is if there's no straight line, please don't assume. Okay? make sure of that. Okay, now moving on to my second bubble question for today. Okay, so what happens? Of course, for this one, I will actually have to give you this side over here. Let's recap. This side over here is actually, sorry for that, 899479. Alright, let's see how we can solve angle QPS. Launching my bubble launcher over here. Let's go. Let's see how do we solve. Alright, so take note. This is 899479. Okay, let me write it a bit neater for everyone else. 899479. Okay, so 899479. Okay, I want to find angle QPS. Take note, I have this side. Angle QPS is here. Okay, we have about 35 seconds left. So for those who have to key in your response, please key in accordingly. Alright, I'm seeing very good responses over here. That's good. Okay, very nice. Last 10 seconds. Quickly key in your response. I understand this question is a little bit hassle. Last 5, 4, 3, 2, 1. Alright, okay, that's good, that's good. Most of you got it right. I would say 50% of you, that's good. But now, how do we actually solve this? Take note, these two are given to me in a triangle. 1 to 9 and as well as 13.2. 1 to 9 and 13.2. Okay, I have another side given over here. I want to find the angle. So what can I do? Again, this calls for, okay, the situation here calls for sine rule. Okay, so that's where we write down. Okay, using sine rule. Okay, so depending on the situation, you have to see how it calls for. In this case, two sides given. The side that's opposite the angle you want to find, it's given as well. So sine of QPS over the side 8.99479 is equals to sine of 129 over 13.2. Solving for sine of QPS. Okay, some of you may have just stopped here, over here as such, so it's 899. Remember to include all my decimals. Sine of 129 degrees over 13.2. Okay, this is equals to 0.52956. Now, some of you have your workings here. Just take note, you will need to actually sort of do the sine inverse in this case because I'm finding the angle. And little mistakes over here, some of you actually round down instead of round up. So take note, when you do the sine inverse of 0.52956, that is where it's equals to 31.97. Okay, so if for the answers ranging there, that's good to see. Most of you got it there, but remember, we round up to one decimal place. Remember, angles always to one decimal place when it's in degrees. So 32 degrees over here. Okay, so I hope you all got this down as such. And last one, very, very simple. Find the angle of PQS. Now let's take note over here. Let me write down what we have. Okay, I have 31.97612 and I have my side. Okay, but take note, don't quickly straight away do my triangle half AB sine C. Please remember during the recap what is the C given over here first. Okay, launching my bubble launcher in 3, 2, 1. Let's go. Alright, so what is the angle C at my side? Okay, I have my first response. This is good. Okay, so remember what is the C over here. Alright, that's good to see that most of you all know the C's over here. Okay, but take note, be very careful. Some of you are falling into the trap, but that's good. Okay, responses are going strong. You have about 20 seconds left. Alright, you have about 5 seconds left. Okay, responses are going good. More than 50% of you got it right. That's good. But let's bring back first. Okay, remember, some of y'all may have said, okay, I have my angle, I have my two sides, I straight away use. But take note, the angle, is it the one included to the side? I know. These are my two included sides. Is it with the included angle of 31.97612? No, right? Included angle, recap, it has to be this particular angle over here. Included. The sides includes my angle. The sides includes my angle. So what happens is this. I have, therefore, I will need to do this. PSQ is equals to 180 because that's the included angle. 180 minus 129 minus 31.97612. Okay, for this, remember to write your property because they are adjacent, not adjacent, sorry. Angle sum of triangles. Okay, writing it out, that's where I have 1902388. From there, that's where you use your half AB sine C. So PQS is equals to half of 8.99479 multiply by 13.2 multiply by sine of the angle. In this case, it's this one. It's not this one, it's this one over here. Okay, so as I'm explaining the thing, try to follow what I am trying to get through here. Okay, so sine of 19.02388. Take your calculator, press it. Remember to do the whole digits. That's right. Be careful. I only want triangle PQS front. So lesson learned over here. Okay. So this is equals to 19.350294. Round off to 3SF. 19.4 cm squared. That's what I have. Alright. So be careful of the mistakes that you might make along the way. Alright. Now this is the revision for the first part. Let's move on to the next. Okay, so with regards to this further application, suppose you have a building. If you are looking from A to T, that's where you elevate your head up because you have to look up. But look at the notation and look at how they say it. Elevation of this location of T from A. So you're looking from A to T. That's why you are elevating. You're looking up. In this case, it's going to be theta 1. Okay, take some time to absorb. This is the first one. Now, I will erase everything over here. And if I repeat for the depression. Depression means what? Depressed means not because of you are depressed, but you are depressing your head. You are looking down. So from T to A. So what you are doing from T. Okay, so from T to A. From T to A. You are looking down. So how depression of the angle works, angle of depression works, is from the straight line, you are looking down. Okay, you are looking downwards over here. Okay, so from there, this is angle of depression. Okay, this is my angle of depression over here. Theta 2. Okay, based on this diagram over here, okay, this is an interesting note. Let's see whether you still remember basic geometry. What can I say about theta 1 and theta 2? Does anybody want to try? What can I say about theta 1 and theta 2? Based on this diagram over here. This is your basic geometry. Very good, equal. Very good, Denise. But why are they equal? Why are they equal? Very good, perfect job over there because of alternate angles. Okay, so just be very, very careful on the notion of your alternate angles. And this is usually the common convention to questions when it comes to elevation, looking up, and depression. Alternate angles may come into play. So do take a look out, okay? Common convention, alternate angles. And also another application that comes to elevation and depression, it's bearings. Okay, so let's go on to our bearings. So how do we do it from the bearings? Recall. Okay, this is a common common mistake that some of y'all may notice, because bearings, it is always, remember, reference to the north line. There are common consensus to common misconception. It's on how the point it's oriented. So example, let's say very simple, a plane. Okay, suppose I have let's say a bird. Okay, it's not a very nice looking bird. Okay, suppose let's say some people may assume, okay, a bird, it flies over here, so orientates over here. So therefore, my bearing should start from here. No, because this is an assumption that the bird, it's oriented that way. It is also possible that the bird, in the end, is this way. So does that mean, if I were to say the bearing should start from the orientation, it goes this way? This is very ambiguous. So therefore, for bearings, we disregard the orientation of the object and just say, oh, okay, for bearing, regardless of how the object is doing, we always start from the north line, which means it's north is pointing up. So first thing, bearings, always remember, you draw the north line. You draw the north line. From that point, in this case, I'm looking for B. This is my north line. And after that, remember, second important thing, I'm always going clockwise. Clockwise. Lastly, bearings, regardless whether it's acute or obtuse, always remember 3 digits. So therefore, when they say 78 degrees, the bearings will be written as, in this case, over here, 0.78. Okay, 0.78, always 3 digits, 0.78 degrees. So take note. So the 2 things you need to take note. Okay, first one, very important, main concept over here. When we do bearings over here, let me remove my very ugly drawing of my birds, okay? When I do bearings, first things first, it always start off with the north line. That's the first thing, okay? Remember, bearings, first one, north line. Second thing, how to measure? Clockwise. Third thing, when you write down, 3 digits. So remember, north line, clockwise, 3 digits. Okay, I hope you all got this down, because that's where we are going to go to our last 4 bubble questions. Alright, so they are a bit heavy, but let's see how you are doing. Okay, launching my bubble launcher in 3, 2, 1. Okay, first question is on bearings ready. I haven't launched it yet. I'm going to launch it now. Alright, that's good. Okay, so Q from R. Where am I measuring it from? Where is the bearing reference from? Very important. Okay, so where is the bearing of from where? I forgot to mention this, but very, very important. Alright, take note, where is the bearing you're finding? Very important. Be careful of your trigo ratios, very important. Don't get tricked. You have about 40 seconds left. Last 30 seconds. Okay, so remember, where should I draw it? Should I draw it at Q or should I draw it at R? Based on my responses here. Last 10 seconds. Even though the clock says 15, don't worry, it's still more than 10 seconds. Alright, most of you got it down. Just wait a little bit longer. Last 5. Last 4. Last 3. Counting down. Alright, most of you got it down. That's good, but I'll still go through. Remember, bearing of Q from R. What does it mean? Bearing of Q from R. Where does my bearing come from? It comes from R. Right? From R. So bearing of Q. So I'm looking at the angle that I'm finding, in this case my bearing, from a specific location which is at R. So where's my north line? North line is here. This is my north line. Now where is my bearing of Q from R? Of Q, because this is where R and Q are linked, from R. So this is the angle I need to find. But you realize, in order to find this angle, what else do I still need to get? This particular angle here, right? So from here, can anybody tell me what is the first step for me to find the green angle? Okay, over here checking your process. For those who have answered correctly, you can share your answers. What can I do to find my green angle over here? Okay, let me give you a hint, because it's a right angle triangle. When right angle triangle comes in, you have your famous 3 acronyms, Tokaso. Which one do we use? Okay, T for Toa, C for Ka, S for So. So just type the alphabet in, T, C, or S. Okay, I will check your responses accordingly to make sure you all check your progress. Alright, I see some response. Alright, very good. Very good, Lim Sing. Very good over there. I see a good response over here. Correct. Okay, so most of you I think got it, including Lim Sing as well. Very good. It's T. Very nice. Very good. Okay, but over here, this is actually more linked to A math. So you can do that as well. But what happens is, try not to do that, Denise, because this one might link to certain mistakes that may happen. If you're able to do this fast enough, that's good. That's actually correct as well. But don't try to mix it up. For A math, it's able to do this. For E math, what happens? They will not know this notion over there. Okay, but you can use this to your advantage. So do not worry about it. Okay, you are still correct. So what happens? Okay, we can find tangent of the green angle first. This is equals to, in this case, opposite over adjacent. Okay, remember, opposite over adjacent. What is the opposite? What is the adjacent? You have to be very clear based on the angle. So therefore, if I were to solve my theta now, this is going to be tangent inverse of 70 over 40. This is equals to, take your calculator, press it, make sure it's in degrees. This is equals to 60.25511 degrees. It is a green one. Now, if I were to find a green one already, how do I find my yellow one? So therefore, my bearing of Q from R. Okay, bearing of Q from R. In this case, when I draw my north line, it's going to be a straight line because this is directly up. Okay, based on the diagram over Q is east of O and R is due north of O. Okay, this is the explanation to why I can assume the line is straight. Because when I draw the north line, when it's due north already, it is straight. Yep. Okay, there is no, it is just straight up because both are pointing north. So that's where I can use angles in a straight line. 180 minus 60.25511. Again, I'm using a property, so it's good to write down adjacent angles on a straight, I hope I'm not writing it, line. Okay, this is equals to, you may forget the negative sign. That's one thing, Denise. That's an answer for you. Okay, and also what happens is this formula is not really known, so you may get confused between E math and A math. But then again, if you were to do your formula, tangent inverse of QRO, okay, you will still get the answer. Okay, you can try negative of 70, 40. You take the tangent inverse, you will get 119. Sorry for that, it's not 114. 119. 119. Again, take note, some of you may stop here, but angles in degrees, it's this one over here. So for Denise, I think you can try. Key in your calculator for tangent inverse of negative 70 over 40. You will get 119.7 degrees. For the rest, don't get daunted. You don't have to do this, alright? You don't have to do this. Again, you don't have to do this. But for those who have some A math background, Some of you may approach to this. Okay? But for Denise, you can give it a try. For this one, give it a shot. Key in this, you should get 119.7 as well. Okay, so while I erase this, with this, let's move on to question B. Alright, question B. Now, bearing of P from O. That is where we have it. Let's see whether you can do this. Launching the bubble launcher in 3, 2, 1. Let's go. Okay, read the question again. Q is due east of O and R is due north of O. So when I draw the bearing, what can I say? Alright, very good. Seems like the responses are coming good. Okay, remember when you draw your north line, and I think if I want to draw it out, it's very obvious, but when you draw a north line out, and your north-south-east line, because when you draw a north line, it's with reference to north-south, east, and west. When you draw it out, it'll be quite easy to see from the reference points. Straightforward, I would say, but again, try it out. Okay. Hint over here on how you would draw your north-south lines. Due east of O, due north of O. What does it actually mean? 30 more seconds. Okay, on my side, I will just digress a bit. I hope you're not hearing any other background noise besides my voice, because yeah, there's a little bit of drilling going on over here, but I hope you are not hearing anything else. Okay, so let me see. For those who have responded, good job over there. Okay, most of you all got it. For those who did not, it might be a little bit of a way on how we write the bearings over here. So, if you later look at this, R is due north of O. Okay, so if I look at it, my north line should be drawn this way. Okay, drawn from O. And the reason why I'm drawing my bearing from O is because the bearing is of P from O. Again, of P from O. Okay, my north line is drawn as such. And after that, where do I draw my east line? Q is due east of O. East of O. So that's how I draw it. And take a look at it. What is my bearing of P from O? It's going to be my yellow angle here. But take note, one part of the angle is found already, 90 degrees. It is just another part of the angle I've yet to find. In this case, you all notice it's this green color line. And from here, can anybody tell me what rule can I use to find this green color angle for those who got it correct? Tell me the rule. There are only two rules, sine rule, cosine rule. So which one? Okay, again, let me write down my first word. Using which rule do I use? Sorry, I'm going too low. Which rule do I use? Very good, Denise. Anybody else wants to try? Okay, using what rule? Okay, I'm seeing certain responses. Alright, the keyword here is cosine. Because if you refer to the formula, the other variation, the angle you want to find, in this case, POQ, or QOP, sorry for that, it's QOP. QOP. Okay, what do I want to find? QOP, because you have all your three sides. So once you have it, you're going to have 70 square plus 111.6 square minus 58.3 square over, take note, 2 of multiplied by my included sides, in this case 111.6. And that's where, take note, just solve it first, 0.89322. Okay, so just be very careful when you apply your cosine rule. The two sides over here has to be included. 70, 116, 70, 116. Basically your B's and your C's. Once you have this, you're going to have your QOP. QOP, just take the inverse of this particular notion. Inverse of 0.89322. This is equals to 6.71929 degrees. And after that, that's where we want to find the bearings. I have the green angle. I know the first one because the bearings of P from, in this case, O. What is it gonna be? 90 degrees plus 2671929. Add them up. This is gonna be 116.71929 degrees. Okay, and from there I need to round off to one decimal place, so 116.7 degrees. This is to one decimal place, so you have to take note, guys. One decimal place over here. Henceforth, my answer number 2. Okay, very good, going good. Now 2 more questions to go. Bubble question number 7. Okay, so certain things you may need, let me just write down for you. Okay, so for this question, you will need this angle, which is what we found from the previous part. Let me just write it out. 2671929. Okay, so I want to find the shortest distance from Q to OP. Okay, this is a little bit how you may wonder, shortest distance, how do I find? But then again, one concept over here will allow you to find it. Alright, launching the bubble launcher. In 3, 2, 1, let's go. Alright, shortest distance. Okay, so link back to the concepts you have learned. Which part over here allows you to get the shortest distance? Very good. I have my first response down. For the rest, give it a shot. What is considered the shortest distance? Recall the formulas in your mind. Okay, I'm not shooting myself. I'm not poking myself. Okay, recall the formulas in your mind over here. So we have cosine rule, sine rule, area of a triangle. What do we have? Very nice. I think most of you got it down based on the response there. That's good to see. For the rest, give it a shot. Okay, so let me give you a hint over here for the rest that are, okay, maybe not. I think most of you have got your responses in. Sorry for that. Alright, doing a good job. Most of you, I think, got it down. That's good, that's good. Okay, perfect. Okay, I think most of you, I would say about more than 66% of you got it down. That's good to hear. Good to see. Now, how will we do it? I think most of you, since you got it, something that links to your mind. Shortest distance refers to the perpendicular distance of from O to QP. So not from O to QP, sorry, from Q to OP. From Q to OP. So we are looking at the perpendicular distance. So perpendicular distance and triangle, you have half times base times height. But I realize we need to find my height over here. So therefore, we need another way to find my area of the triangle, which is, okay, our half AB sine C. So half times, that's where you just fill in your formula, A, B, remember my included sides, don't use 58.3, sine C, which is in this case 2671929 degrees. Okay, this is then equals to, type in your calculator, 1756.21473. Okay, from there, remember your meter squared. Sorry for that. From that, therefore, what is another variation? We know also that area of this triangle, since is equals to my value above, 1756.21473 meter square. This is also equals to half times my base times height, which is h. Sorry for that. H over here. This is equals to 1756.21473. After that, all you need to do, solve it as accordingly. What is h? H is just 1756.21473 21473.56. Okay, you know what? I'll just write the number 21473. Okay, times 2. Okay, divide by 111.6. That's how you get the height. 3747338. Round off to 3SF, because it's the height. 375 cm, not cm, sorry, meters. This is in 3SF. Therefore, number 1. Alright, so just take note of the cosine rule, how you all use it as accordingly. Okay, and remember to read the question. Okay, remember to read the question. Okay, I want Q to OP. Now, last one. Bubble question number 8 before we call it a day for today. Okay, now I have a drone that is hovering. So this is a bit hard to see from the diagram. I have a drone that is hovering vertically above Q. So before that, I will need this. And I will need the length over here, which is 3147338. Okay, I will need this. Okay, how do I find the greatest angle of elevation? Okay, recall and understand why I provide this. Okay, launching my bubble launcher in 3, in 2, in 1. Let's go. Alright, note to moderator. Take note. Hovering vertically above Q. What does it mean? That means on Q over here, I'm unable to draw it because it's 3D. That's the hint over here. I have it as 3D. Okay, hovering above Q, that means it's above here. And then suppose, let's say I call this point X. So since this is 78, angle of elevation. What is it trying to say? This is the very biggest hint already. I'll stop here. I mean, I'm not going to stop the lesson now. I will stop my working here. So I'm looking up. What does it mean? Alright, I have 20 seconds more. Okay, that's good. Recall what is your opposite, what is your adjacent, what is your hypotenuse. I think some of you are getting confused. Last 3. Okay, some of you are lost, but okay, this one I think I have to go through. Now take note, hovering vertically above. That means if I'm able to protrude a point diagonally up, that means it goes through from here. Okay, what happens is, if it goes up, it is hovering above Q, and henceforth, can anybody tell me what is the distance QX? What is QX? You realize this way, if I look up, isn't this my QX? 3147338. Because from that point I'm looking up, so the reference distance I'm looking at, looking up, distance, going up, is going to be this length over here. So once from here I look up, hovering vertically up, angle of elevation, looking upwards, won't it be this angle over here? So once you have this, you realize, okay, opposite, adjacent, 2. That's where I have 78 over 3147338. Okay, therefore applying this, I have my theta, tangent inverse of this ratio over here, 3147338. This is equals to 68.02568 degrees. And therefore, rounding off to 1 decimal place, 68.0 degrees. Alright, so you have to be very careful on the elevation and reading it in 3D. Very important. Alright, with that, that sums up for today's lesson. And recap your concepts for those who wants to try. TIY. TIY is actually posted already, so do give it a shot on the TIY. But this is what we have done for today. Revision of Pythagoras theorem, trigo, and further trigonometry. Lastly, applications of trigonometry as well. So there's a TIY for it. Okay, apologies, I did not post it here, but there's a TIY. Give it a shot. It actually combines every concept over here: angles of elevation, depression, shortest distance, every question, 6, 7, 8, and a little bit more. So do give it a try. Alright, and that's it for me today. Thank you for joining me in today's revision. I hope you all get a little bit clearer on the concepts. Until then, this is teacher Jason, and I hope to see you all once again. Alright, take care everyone. Stay safe. Bye bye.